discovered when we finished example 2 is called the factor property. That if you wanted to factor this and they didn't give you any ones to try, which ones should you try? You have to try something that is a factor of that last one. So this one factors out to be x minus 1, x minus 2, and x plus 5. And all of those numbers multiply together to give us the 10. So the last number here, this would tell us our possibilities could be plus or minus 1. It could be x plus 1 or x minus 1. It could be plus or minus 2, plus or minus 5, or plus or minus 10. And what we need to find out is which one of those gives us a zero remainder, either with synthetic division or with the remainder theorem where you plug it in. So usually I start with the remainder theorem with 1 and negative 1 because that's the easiest mental math. If they don't work, usually synthetic division is better after that. But in this case, if I plug in positive 1, 1 plus 2 minus 13 plus 10, perfect, it works. So plugging in positive 1, so if I said let p of x equal this, and I find out that p of 1 equals 0, this means x, is it plus 1 or minus 1, is a factor. If you plugged in 1 and got 0, would it be the x plus 1 or the x minus 1 that's the factor? It would be the x minus 1. Because plugging in the 1 minus 1 gives you the 0. And then you would do, once you find one factor, then we would do our synthetic division, 1, 2, negative 13, and 10. If you're dividing by x minus 1, a positive 1 would go out here. Bring down the 1, 1, 3, 3, at negative 10, negative 10, 0. And you would be able to start to factor that p of x is equal to the x minus 1, and our quotient is x squared plus 3x minus 10. And once you get a quadratic, then to factor completely, you can just factor that quadratic like you normally do. That is going to be our strategy for factoring completely. So let's write down that strategy. Go to our example 3. I'm going to use proper mathematical terms here. So in our example, that's the 2. The constant term is the term without any x's. Use the factors of the constant term to find one factor. Once you find one factor, and how do you do that? Either with the remainder theorem or synthetic division. You can choose. It's up to you. You're going to need synthetic division anyways because you need to write the division statement redo steps 1 and 2 until you get a quadratic equation. So sometimes you're going to start with an x to the 4 function. And if you find one factor, your division statement will have your factor and an x cubed. And then you have to redo process 1 and 2 with your x cubed function. Find another factor that works. Rewrite your division statement until you get a quadratic equation. So we're actually going to we'll do one example here is with the x cubed, and then we are going to find one from the homework that's an x to the 4, just so that you can see what it looks like when you have to repeat things. Make this a little smaller and put it off to the side. So, we'll use R2. First of all, it's often very helpful to call this P of x so we can do things shorter. The constant term is a 2. That means if there's factors, they're only going to be 1 or 2. So it's pretty straightforward here. I'm going to try 1. And if I plug in 1, it's 3 minus 4 minus 5 plus 2. Does that work? That gives me -4. So that's not a factor. Probably good I chose 1 to see what does it look like when something doesn't work. So 1 didn't work. Because if I plugged in 1 for x, I have 3 minus 4 minus 5 plus 2. It equals -4, not a factor. So I have to try another one. -1. Well, this would be 3 times the -1 cubed, which would be -3. 4 times the -1 squared would still be -4, because a negative squared is positive, times the -4 would still be negative. -5 times the -1 would be +5, and then +2, and now things are good. If I plug in -1, and I get 0, that means x plus 1 is a factor. And then I need to write my division statement with my factor. So I go to synthetic division. They're already in the right order, and I don't have to add any zeros. So remember, when you use synthetic division or long division, we're always double checking that it's written in order from highest degree to lowest degree. And we're making sure that there's no term missing, like we have x cubed, x squared, x, and a constant, so we don't have to add any zeros. And since we're dividing by x plus 1, we would put the opposite side -1. Okay? So where do you get confused in this unit? It's not very hard, but do you see how things like switch signs all the time? So we just have to be careful with that part, right? If p of -1 made it 0, then x plus 1 is the factor. And if you're dividing by x plus 1, well, then we put the -1 into synthetic division. Then we bring our number down, 3, multiply and add, multiply and add, multiply and add. And this is the confirmation or the double check that we did it right. We should get that remainder to be 0. So now our division statement, and this is why it's nice, you don't have to rewrite all of that because you said let p of x equal, so we can just go p of x equals, we divided by x plus 1, and we're left with 3x squared minus 7x plus 2. Okay? Do we have to continue steps 1 and 2 again? No, because we got a quadratic. We got an x squared one. So now to finish factoring, we can factor this like normal. To get the 3x squared would have to be 3x and x. 2 would have to be 1 and 2. Now it's going to make a difference if you put the 2 here or the 2 here. If I put a 2 on my outside, it becomes 6. 6 and 1 can make 7, especially if they're both negative. It'll make -7. And we've factored completely. I'm going to pull up breakdowns from the homework. I'll tell you which ones you can circle from the homework. For this one, you can circle questions 5, 9, 10B, and 11. So I'll write that down for you as well. And we're going to do 11B together, because I'm going to show you how it works with an x to the 4 graph, and then I'm going to show you sometimes there's a shortcut for some of these questions. But first of all, we're going to do 11B like normal, so I'm going to just say I'm going to let P of x equal that x to the 4. And so our constant term is the 4, so it could be 1s, 2s, and 4s that could possibly make this work. And I'm going to try 1 first. I get 1 minus 5 plus 4. Oh, how lucky we are. We get 1 right away. So if 1 works, that means x minus 1 is a factor. And I find that writing this step out really helpful. So for those of you that didn't hear which questions out, I said I'd write them down as well. You circle 5, 9, 10B, and 11. But we'll continue to do this 11-1 together, 11B together. So I found out one of my factors is x minus 1. Now when I go to my synthetic division, this is one where things are missing. Right? There's 1x to the 4, but notice there is 0x cubes. There is a negative 5x squared, but there are 0 x's. And then there's a 4. And if I'm dividing by x minus 1, I put the opposite 1 out in front. Multiply, add, multiply, add, multiply, add, multiply, add. And once again, really good that we get that remainder of 0. So we can write our division statement. Now it's important when you write your division statement, it is an equation. So we write P of x equals, we divide it by x minus 1. And this is our answer. Some people start writing it backwards, because you know that your last one's your constant, then your x, then this one will be your x squared, and then this one will be your x cubed. So you make sure that your all of your powers work out the right way. But the other thing you can do is you can say, I started with an x to the 4. So if I took out an x, this has to be an x cubed as the next one. So, we did it, but we still have an x cubed. So we have to repeat steps 1 and 2. Notation-wise, sometimes students will do this. They'll say, let f of x equal this one. Because we already used p of x once. So now I have to factor this. And I'm going to try, right? My constant in f of x is still a minus 4. So it's still going to be a 1 or 2 or a 4. I'm going to try 1. Even though I know it's not going to work. 1 plus 1 minus 4 minus 4 equals negative 6. And some people say, oh, well, it makes sense that it didn't work because you already tried that and it didn't work. But sometimes you can get the same one twice. So just because it worked once, it could work again. But now if I try f of -1, that would be -1 plus 1 plus 4 minus 4. Sure enough, that equals 0. So I found out that x plus 1 is a factor of f of x, that part in the purple bracket. So I'm going to take that part in the purple bracket, and I'm going to do my synthetic division with 1, 1, -4, and 4, -4 again. And if I have an x plus 1, a minus 1 would be out in front. Bring down the 1, multiply, add, multiply, add, multiply, and good, I got my remainder of 0. But now when I go to write my division statement, I'm going to still, because I want to factor p of x, I'm going to scroll up here. So there's our p of x. Our p of x had an x minus 1. And now this purple bracket, we said we can pull out an x plus 1, and we're left with x squared plus 0x minus 4 as a result. So I find that an area where sometimes students run into problems is just being careful with notation. So we had p of x here, we already got the x minus 1, that x minus 1 is out. Then we worked with the new part, found a new factor of x plus 1, so now we have two factors for p of x minus 1 from before, and now an x plus 1. And what's left is just the x squared minus 4. Now we've got a quadratic. The difference of squares. So now we can factor completely. So when you have an x to the 4, and you go through the process, you're going to have to repeat steps 1 and 2, because after your first factor, as we saw here, we were still left with an x cubed. So we had to do our steps again. Now I said this one had a shortcut. So I'm going to show you the shortcut. Sometimes there's a shortcut for x to the 4 ones, and the shortcut happens, here I got to see the question again, x to the 4 minus 5x squared is it minus 4 plus 4? Plus 4. And the shortcut happens when your x to the 4 really looks like a regular quadratic. Can you see that a regular quadratic, and I'm going to show you the tiny little trick you can do in between. Choose a letter other than x. Any choices? Sorry? Y. Let y equal x squared. Because then I can rewrite this. Instead of 5x squared, it would be minus 5y. And what would it be instead of x to the 4? It would be x squared times x squared, which would be y squared. And if I do that, this is a quadratic. Can you factor quadratics? Yes. You can factor quadratics because this is easy. It would have to be y and y, 4 and 1, and they would both be minus. No problem. And then you can change them back and say, oh, this is really x squared minus 1 and x squared minus 4. And these are both quadratics, and they're both differences of squares. So this factors to x plus 1, x minus 1, x plus 2, x minus 2. And did we get exactly the same answer that we did with all that synthetic division and long division from before? Sometimes with x to the 4th, that is a shortcut. It's a shortcut if you could think of the x to the 4 as a quadratic. Because really, this is x squared squared minus 5x squared plus 4. That's a quadratic with an x squared instead of just a regular x or y. But the substitution, what I did in blue, can make that very helpful. Okay? Most of the time on the exam, though, they're like, what are we teaching you in grade 12? We're teaching you the synthetic division, the remainder theorem. I've never seen the shortcut come up on the exam, because then it's just testing whether or not you can do grade 10 factoring. And they don't get to test any of the synthetic division. Yeah, perfect. If I have one like this on a test, or if this one comes up on an exam, that's perfectly fine.